and with the new background as well, we're all
I
set.
know,
And it's
I
it's not
know.
even a virtual. It's not even virtual, which is great. You can
It's
actually touch
lovely.
that stuff, right? You can actually touch it. It is real.
It is real.
Brilliant, brilliant. Hello and welcome to the Cloud Therapist channel. I'm Richard Simon. Is the operating system dead? Is the OS as we know it dead? That's the topic for today. And I have with me Cheryl Hung, who's back on the channel. Great to have her back on again. It's been some time to discuss that very much that particular topic. So welcome back, Cheryl. Good to see you again. How are you doing?
It's really good to see you too, Richard. Thank you for having me back on. Yeah,
Absolute
things are
pleasure.
good.
Absolute pleasure. Always good to see you. So Cheryl, just give us a quick sort of intro to yourself, please, and kind of, what you've been up to recently.
Sure. So my name is Cheryl. You can find me online at Cheryl. I work for Apple, but I'm also very active in the open source community and around Kubernetes and cloud native. I'm the founder of the Cloud Native London meetup, which has over 6,000 members. So yeah, that's kind of my interests.
Fabulous. Yeah. So just a quick reminder for viewers, if you're kind of been regular on the channel and sort of checking out my videos, please do consider subscribing to my channel to really support me. That would be really helpful. I'd appreciate that. Okay. So yes, operate is the OS there. That's kind of what we're going to talk about today. Slightly controversial, might sort of trigger some interesting discussion points. So one of the kind of first things that I wanted to sort of highlight was obviously the move to cloud is kind of making a lot of changes in terms of how people are sort of deploying their services and applications and so on. So I'm kind of seeing the traditional operating system becoming more irrelevant in some of those newer platforms, containerization, the kind of microservices and things like that. What's kind of your take on that, Cheryl?
So I agree with this. I think this is all part of a trend of moving up the software stack, um, reducing the complexity of the things that you have to manage by packaging them in containers, using Kubernetes typically to run them at scale. So more and more, I see the same thing, that the operating system that you're running it on top of is not really a topic of discussion.
Okay, cool. Yeah, I mean, I think we're pretty much agreement there. There's that kind of what the operating system used to do and offer you in the data center is kind of being de-emphasized. I would
Yeah.
say
De-emphasize
in
is the
cloud.
correct word, because there's always things where you actually still need to interact with the
Yeah,
operating system.
yeah.
My background is in storage, and storage is one of those layers where it's very hard to completely virtualize everything. But I definitely agree with you.
Yeah. So, and again, with the, sort of the advent, as we said, of things like containers and so on, could we get away with just running a very small Linux kernel, for example? And also, with the advent of things like WebAssembly, for example, we're seeing even smaller runtimes. So that unit of computing might actually get even smaller than the sort of containers we're used to at the moment.
I mean, one of the trends that we also have seen is functions as a service.
Mm.
I mean, it's not very widespread, but I think that was a kind of culmination of like break it into even smaller pieces and just run functions using Lambda or using some other functions as a service platform.
Yeah, yeah, no, absolutely, and that's actually a whole question, a whole area in itself as well to explore. And kind of, we don't even really care how that's run, as long as the function kind of does what we want it to do, or we inject the functions that we want into that sort of environment, right? Okay, so I mean, obviously this doesn't diminish anything from the sort of the desktop side, the client side of things. The sort of the Windows. Sort of Windows 11 or Linux desktops, whatever, Chrome OS, etc. Those are
Right.
still going as they are. I think
Or iPhone, iOS.
indeed, or Android and so on. But yeah,
Yeah.
and this is definitely kind of more focused on the on the server side, but we are obviously definitely seeing this trend with the advent of these kind of new technologies and so on. Okay, so what is the kind of what is sort of cloud natives sort of role in this? I'm kind of interested to learn a little bit more of kind of get your take on sort of how cloud native is affecting because of its architecture and the way that it does things. How's it kind of affecting the traditional sort of full fat operating system?
Mm. So, uh, cloud native, the whole kind of concept of it really is to abstract away the application from the underlying architecture, the hardware that it's running on, the individual box, the server that it's running on. Um, so the whole kind of motivation behind cloud native is to really separate those and keep those concerns um, independent of each other. And you do that because that means you can, for example, if your server goes down over here, you can bring back a container over this side without it having to match that environment underneath. So the cloud native effect, I think, from the beginning was really to de-emphasize the server, de-emphasize the operating system that it's running on, de-emphasize like having the right libraries, the right versions of libraries in the right place, all of these things that classically you would have to worry about.
Yeah, so I see still sort of posts every now and then on LinkedIn where they kind of say, yeah, Linux is kind of leading the pack on, whatever sort of environment or something like that. And I think that's fine. But the emphasis for cloud and specifically cloud native, I think, is more towards, as you said, moving up that stack and focusing more on decoupling the application, breaking up the application, and the more I think that you do of that, the less important those kind of lower layers or the layers below that, sort of become. What's your what's your thought on that?
A few years ago, Jim Zemlin, who runs the Linux Foundation, made an interesting comment about Kubernetes, which was he called Kubernetes the Linux of the cloud. So the idea was like Kubernetes is now your kind of layer that you run on top of the cloud, and everything underneath that is abstracted away. It's and it's still Linux based, but you only need to worry about Kubernetes. You don't need to worry about anything under that. Which I thought was just a very kind of nice metaphor for understanding how you approach cloud, or how you approach the architecture from a cloud native perspective.
Yeah, and there's certainly been lots of sort of alternatives in that space. So, Apache Mesos and maybe even to a degree hyperconverged infrastructure, as we were sort of transitioning out of the data center and before we kind of jumped into cloud fully, there was that sort of interim, sort of stage as well. So yeah, so I definitely agree with that. Now, in terms of numbers, I think we both tried very hard to find some of those. If anybody's listening to this or reading this, or viewing this rather, and if you do have some hard numbers on this from some research company or something, drop them in the comments because we'd love to see it. I think, but we couldn't really find anything that actually said, in the three sort of major public cloud providers, Linux is the sort of the dominant operating system, or it's the kind of this runtime or whatever. So that was kind of a little bit disappointing. So we couldn't really find that.
I mean, but anecdotally, both you and I think, and probably most people working in this space realize that Linux is extremely, extremely, extremely common. Vast majority of applications assume Linux underneath. And if you're running on Windows, then you have to do a lot of special work and special cases around that.
Yeah, and those kind of don't really sort of meet at all. So it is a kind of a.
But I would still love to see numbers. So yes, definitely, if you know of any numbers, any stats around what are the most commonly deployed operating systems in these cloud native stacks, like please do share.
Yeah, that would be interesting, and definitely kind of how much of the workloads in Azure are Linux based, for example. That'd be an interesting number to look at. But yeah, so I mean, I think because of the cloud native effect, and because of the way the architecture kind of works, and kind of reflecting back, we've kind of started with things like mainframes, went on to mid-range. Then you had kind of Linux and Windows and all sorts of server operating systems. And now we're on to sort of containers that kind of really strip down the operating system to that sort of core requirements, and then kind of future architectures you mentioned, sort of function as a service and so on. We don't really even care how that's running, as long as the function that we want is executed. That's, I think, where I see the emphasis for that sort of hardcore operating system, or rather that full fat operating system, and all the things that we kind of wanted to do with it in the data center, and how we wanted it to operate in the data center is not really all that relevant for us in the cloud. That's maybe another point. What's kind of your thoughts on that?
So how are you distinguishing like data center? You're sort of thinking private versus public cloud?
It's more within the operating system. We put in a lot of emphasis in the operating system, in the data center. So we expected it to do a lot of the security, the networking, the storage was all kind of combined in the OS. And then the app didn't really have to worry about that. It would just kind of make a request and then the OS would take care of that. But obviously in cloud native architecture, we're seeing a lot of that sort of being decoupled and kind of expanded out into other layers that kind of take care of the security and the networking, and kind of pointing to persistent storage and things like that.
Yeah, I mean, for good reason, right? It's a lot easier to manage these things in software abstraction layers that are independent of the hardware and the data centers and the server racks that they're running on. So I think this trend is going to continue.
Right. Yeah, absolutely. Yeah. So, okay. So, I mean, one interesting in my search for those numbers, for those stats numbers, I did find a quote from IDC. I can't remember when the article was published, but I'll put a link in the description of the video. I think it was actually a Bloomberg report that was quoting IDC. So IDC, and I quote, said, the operating systems have for decades been at the forefront of IT, yet with the drastic shifts over the past several years in terms of cloud uptake and the trend towards next generation use cases, including high performance computing, so HPC, and artificial intelligence and machine learning, so AI and ML, the dynamics of the operating system market have shifted considerably. It has become even more ever more incumbent on enterprises to consistently reevaluate their infrastructure strategies as they pursue and undergo digital transformation. So quite a long sentence, but that for me just says, is the OS license that you're paying right now, do you still really need to kind of have that when you move to the cloud? That's kind of what it boils down to me.
Interesting, because definitely license costs is huge, can be huge for enterprises. And one of the benefits of moving to a cloud native stack is you no longer have to worry about how many operating system licenses you have to pay for, how you're going to manage them, how you retire them, and then when you need to do a big move to a new operating system. So I could definitely see that as being a big factor for enterprises.
And that moves us on nicely onto the kind of the fundamental problem of the full fat OS. So licensing and costs is one thing. I think the sheer size these days, and especially when you're in the cloud, and kind of bringing in a 10 gig full fat operating system, 15 gig if you're whatever, 20 gig even. I don't know what sizes they are at the moment, but kind of certainly Windows Server and some of the sort of the Linux distributions, the enterprise distributions are tend to be quite hefty, especially if you're maybe downloading or installing lots of modules that they require or that you require for your workload. So all of that cost, size, license is all part of that.
Right, because that was one of the issues with VMs, right?
Yeah.
Like, yes, you can run multiple VMs on a single server, but each VM has to have its full operating system. And then you have all the problems of maintenance and patching and upgrades with each of those VMs. And they take up so much space on the server that you're not actually getting very good, your utilization in the sense of useful utilization is pretty low. From an enterprise point of view as well, once you've started buying, server racks and equipment, you want to make the best use of what you've bought. So stripping back that operating system so that, the number of operating systems you're running, does that make sense?
Yeah.
Means that you save that cost. You can use that cost on other things.
Yeah, and so I'm just thinking about, as you said, kind of the virtual machine is a full emulation of a physical server, right? So that whatever software you run on top of the OS and the application, they're none the wiser. They just think they got their own physical machine, and they just get on with it as they were doing before. So there's kind of a status quo sort of disadvantage then, that you just continue doing the same thing with virtual machines, whereas with a containerized environment and beyond, it's kind of you've got a lot more freedom in terms of how you you operate, especially if you maybe put together a service mesh, and that kind of gives you a huge advantage. So it's that kind of static, just continue the status quo, static sort of approach to how we're doing things. Probably not the best thing to migrate that into public cloud. But also the speed. I mean, we mentioned size of the virtual machine, and then you put the full fat operating system on top, and that's gigabytes worth of storage versus megabytes worth in terms of containers. But also speed. So it's just not just the VM spinning up, and we all know that's kind of infinitely slower than spinning up containers, but also the speed of the operating system itself is kind of another huge layer. What's kind of your take on that?
Well, of course, like with a full operating system, every system call that you're going to do is going to be translated through multiple layers before it hits the actual hardware. And speed is a virtue, right? You want your customers to have a good experience. You want your app to be able to serve your customers faster. So anything that's going to get in the way of that ultimately translates to lost business, a poorer customer experience.
Yeah, and also you mentioned the space as well, kind of the operating system or the servers that we need and the rack space that we need for. And that's not rack space, the company, by the way, just rack space.
Physical
space.
Rack.
Yeah, the physical racks. I never kind of thought actually that the digital would affect the physical. That's really interesting way to look at it, because you've got all this kind of very hefty sort of gigabytes worth of operating system and applications and whatever and data. That's actually going to affect something physical. It's going to go right. We're actually going to need more physical stuff to put in to cater for those digital things. That's kind of an interesting way to look at it.
I mean, we forget about it because we're not, most of us, if we're working in cloud, don't touch the physical data center stuff very much. But it takes physical space, it takes resources, it takes energy.
Exactly. Yeah. And that's, I think, all kind of repercussions of, and implications of kind of, doing that or continuing with that sort of data center sort of approach and architecture.
I do like as well the point that you made about upgrades. One of the benefits of a cloud native approach is that you don't really have to worry about upgrading the underlying operating system. You kill this node and you bring up a new one with a new version, and you just migrate everything over, and it should just work. And it is really a problem when you have a full fat operating system with a bunch of patches on it, with a bunch of stuff running on it. Upgrading that now becomes really, really difficult.
Yes, and that's always been the case in my experience from the sort of distant past. Sometimes I would actually have problems just upgrading the service packs of the operating system. So if I went from one service pack to the other, it would break something somewhere else, or it would break the application, and the application would only be compatible with service pack version whatever, but not the newer service pack. So it's kind of got a little bit crazy with patches and updates and things like that. So completely agree with that. Okay, so I think we've maybe picked up on a few interesting things there about sort of size, speed, security, licensing costs, maintenance, upgrades, and things like that. I think all of those kind of really are quite good defeaters when it comes to talking about sort of using or continuing to use sort of the operating systems that we've had in the data center. So just kind of doing a quick outlook onto the future. Where do you kind of see this going? What's kind of we've obviously seeing a march towards microservices with containers and things like that. What's kind of your take on it? What have you sort of heard from corporates and people that you can maybe talk to in the meetups and so on?
I really do truly agree with this idea that the OS is dead. It's kind of irrelevant. I don't think people even care about what distribution, like what Linux distro they're running on, which to me is an indicator that if you assume that you're running on Linux, then beyond that, the OS is dead. I do have a couple of caveats here. One of them is, for example, the ARM services that are coming out now. That's going to require images that are aware of those different architectures and multi-arc like images, Docker images. So that's one area where I see there's still a bit of you can't completely abstract away from what's underneath.
Yeah, I think I would agree with that. And I think that's, for particular type of workloads, you still need certain elements of what the full fat operating system used to do in the data center. And if those are moving into the cloud, and we see, with the likes of AWS kind of producing their own ARM-based processors now and offering those for, those specific workloads like HPC and AI and ML and things, and even data related ones. So I would see that as still requiring, some kind of sort of full operating system image. But I think, again, that's only because of the architecture of the application. And then eventually, hopefully, we'll kind of move from that initial stage of, first foot in the cloud and kind of move from that into, again, back to microservices and containers and things like that. And we're gradually seeing some of that going across as well.
Yeah, exactly. I think we are moving towards these smaller and smaller units of computing, going from physical data centers towards virtual machines, towards containers, maybe towards functions as a service. But at the moment, I think containers is definitely the most widespread approach across the industry.
Yes, definitely. And I think that's probably going to, the industry needs to catch its breath. So I think we're going to stay with containers for a while.
I think so as well.
Yeah, I think so. And obviously, I mean, we kind of mentioned HPC and AI and ML and stuff like that, but also, cloud video gaming. Although I actually heard so yesterday or just today that Google has actually now stopped their Stadia platform, which was interesting news. But with I think the traditional sort of players in the video game market will probably continue and offer their services in the cloud as well, so people can actually play the same game, whether it's on a tablet, mobile, or the traditional video game console. So we are kind of moving towards sort of centrally run applications. And I did make a LinkedIn post somewhere. I did make anecdotally a joke about, is the cloud becoming the next mainframe? And we talked about that just now when we were kind of just prepping for the call as well.
Yeah. I mean, I think we will see, well, I wouldn't be surprised if we saw cycles of kind of convergence and deconvergence. There are benefits to running things centrally. You can be more efficient, you can have better control over it. There are also benefits to pushing stuff towards the edge. You can package things, more conveniently. You can get a better user experience because they're converged onto the same hardware, so that you get a better, faster user experience from it. So I think it might be like a 20-year cycle if it actually comes out, but I could see it kind of converging and deconverging.
Yeah, excellent. Okay, was there any other sort of final thoughts that you had on sort of the whole this title, controversial title that I decided to pick for our talk?
I just want to say, like, I think this has been really fun to chat about this. I feel like I've learned a couple of things as well, and thought about from the enterprise point of view why you wouldn't want to, why there are difficulties with running full fat operating systems. So yeah, just want to say thank you for having me on the show.
Pleasure. Always great to have you on, Cheryl. Yeah, I think that's it for us for this particular talk. I just want to say again, thank you for Cheryl for all your insights. Really appreciate your thoughts. All the stuff that we've talked about and then some, we're going to have. I'll include all of that in the description of the video. Yeah, and that's it. And we'll see you next time.